Hello everyone. So what we're going to look at today is really jumping into these stoichiometry conversions, and you're going to need that molar ratio conversion that we did earlier. So this particular slide is going to go over two examples of how to go from mole to gram of different compounds. So remember, you're going to need molar ratios for that, and don't forget how to go from mole to gram. So we're going to use the same equation that we used in the molar ratio video of the aluminum oxide decomposing into the aluminum and the oxygen. Remember these blue numbers, those are your coefficients, and those are your recipe numbers. So if I have 2 aluminum oxides going in, they're going to break down into 4 aluminums and 3 oxygens, and those numbers are what's going to be used for your molar ratio. So here's our first problem. And the problem states how many grams of aluminum will be produced when 2.8 moles of aluminum oxide decompose. Now, when I approach these stoichiometry problems, I like to first write out what are they giving me and what are they asking me to do, because it helps me figure out what I need to do to get to the answer. So I like to always write out what are they giving me, and where do I need to go with that? So they're asking me how many grams of aluminum. So how many grams of aluminum will be produced when 2.8 moles of aluminum oxide decompose. So there's my 2.8 moles of aluminum oxide. So I'm being asked to go from 2.8 moles of aluminum oxide to how many grams of aluminum. So there's two things to note here. We are changing units. We're going from moles to grams. And we are changing compounds. We are going from aluminum oxide to the element aluminum. So we're going to need two conversions here. We're going to need to go from moles to grams, and we're going to need to go from one compound to a completely different element. So remember, when you go from one element or compound to another, you're going to use molar ratios. So the next thing that I do is I write out what they're giving me, so the 2.8 moles of aluminum oxide, and moles of aluminum oxide has to be on the bottom, because remember, that'll cancel out the moles of aluminum oxide. So that means I need my molar ratio from the chemical equation to help me convert from aluminum oxide to aluminum. So it's 2 moles of aluminum oxide, I get that right there, to 4 moles of aluminum, I get that right there. So now I'll be in moles of aluminum, but I'm not done because I need to get to grams of aluminum. So now you're going to go from moles of aluminum to grams of aluminum. So you're going to have your moles of aluminum right here. So that means moles of aluminum will be on the bottom. And there's my molar mass of aluminum. In this case, I don't have to do any calculations for this. I just have to look at the periodic table and find out the molar mass of aluminum. So now my moles of aluminum will cancel, and I'm in the unit that I want, which is grams of aluminum. There's grams of aluminum. So if I had this with my brackets, I would have a line across here, and then 2 vertical lines, and I would put into my calculator 2.8 times 4 times 26.982. I'd hit equals and then divided by 2 times 1, which is 2. Or again, you can enter it exactly as you see it into your calculator with your parentheses, and you'll get an answer of 151.1 grams of aluminum. So this is one example. Next example. How many grams of oxygen will be produced when 0.78 moles of aluminum oxide decomposes? So again, just like before, I like to write out what are they giving me and what are they asking me to do. So they're giving me 0.78 moles of aluminum oxide, and they're asking me how many grams of oxygen will that make. So they're giving me 0.78 moles of aluminum oxide. How many grams of oxygen will I get from that? So just like before, start by writing out where you're starting from. I have to convert moles of aluminum to moles of oxygen, right? So I'm going to have my 2 moles of aluminum oxide on the bottom, my 3 moles of oxygen on the top. Again, these numbers are your molar ratio, and they come right from the equation. There's your 2 aluminum oxides and your 3 oxygens. Now I'm in moles of oxygen, but I'm not done because I have to go to grams of oxygen. So I'm going to have my moles of oxygen here, moles of oxygen down here. This right here is your molar mass of oxygen times 2, because remember it's O2, so it's the 15.999 times 2 because I have 2 oxygens. Then you do your math. Again, with my brackets, I would put 0.78 times 3 times 31.998 in my calculator. I'd hit equals and then divided by 2, or you can enter it right into your calculator as you see it. Don't forget your parentheses. And you get 34.4 grams, and this should say O2 there. So this is going from mole to gram of one compound to another. Right? Now, let's take a look at the opposite. What if you want to know how many moles of aluminum will be produced when you start with 3.28.3 grams of aluminum oxide? So again, write out what they're giving you. This is what I'm starting with, and they're asking me how many moles of aluminum will that make. So I write out what am I starting with. So now I'm starting with grams. So remember, when you go grams to moles, you're going to need your molar mass, and in this case, molar mass has to be on the bottom so that grams cancel. This is calculated using your periodic table. Add up your 2 aluminums and your 3 oxygens. That's how much mass 1 mole of aluminum oxide has. So now I'm in moles, but I'm in moles of aluminum oxide. I need to go to moles of aluminum. So I need my molar ratio from your equation, right? 2 moles of aluminum oxide will give me 4 moles of aluminum. Now I'm in moles of aluminum, which is what I need to be in. So in your calculator, I'd put 3.28.3 times 1 times 4, hit equals, and then divided by, and in this case I would do parentheses, 101.961 times 2, close parentheses. And you'll get 6.44 moles of aluminum. Last problem, how many moles of aluminum oxide will be needed to produce 124.3 grams of oxygen? And that should be subscript, sorry about that. So start out by writing, what are they giving me? They're giving me 124.3 grams of oxygen. What are they asking me to turn it into? Moles of aluminum oxide. So again, I'm changing units and I'm changing compounds. So write it out. This is where I'm starting. I'm going to need my molar mass of oxygen, right? To get it into moles of oxygen, because that's how you go grams to moles. You use a molar mass. And then to get it from moles of oxygen to moles of aluminum oxide, I've got to use my molar ratio. And again, these numbers coming right up here, right? So 3 moles of oxygen. Moles of oxygen is on the bottom so that these cancel. 2 moles of aluminum oxide on the top. Do out your math. So in my calculator, I'd have 124.3 times 1 times 2 equals, and then I'd have divided by parentheses 31.998 times 3, close parentheses, and hit equals, and you should get the 2.590 moles of aluminum oxide. So these are examples of going from moles to grams and grams to moles, and changing from one compound to another. So in another video, I'm going to walk you through how to do one of these from the worksheet that I'm going to be giving you. So stay tuned for that.